Hi everyone, it's Lauren Hawker-Zaffer. Welcome back to Redefining AI, the tech podcast. I'm an educator and I'm taking you on an educational exploration into the fascinating minds of those that embody and forefront all you need to know about artificial intelligence, machine learning, insight engines in the insight era. This episode is called Power and Prediction. And to discuss this, I've been joined by Avi Goldfarb. Avi is the Rotman Chair in Artificial Intelligence in Healthcare and Professor of Marketing at the Rotman School of Management, University of Toronto, and the Chief Data Scientist at the Creative Destruction Lab. His research focuses on the opportunities and challenges of the digital economy. Avi co-authored the best-selling book Prediction Machines, and his new book, which is also a bestseller, Power and Prediction, was published in November 2022. Now, I've invited Avi on to Redefining AI today to talk about his literary efforts and success with Power and Prediction. What is the book all about? So let's dive into this conversation and welcome Avi. Welcome, Avi, onto Redefining AI.
Thanks, Lauren. It's great to be here.
It is wonderful. I've not had a guest from Toronto on the show, so it's a first. It's really nice to have you here, and I'm looking forward to the discussion very much. So I think that one thing that we like to get started with, Avi, is we like to make our listeners feel a little bit more comfortable with the guests on Redefining AI. So what should our listeners know about you? Where are you on your own journey, and what encourages you to pursue your current path?
So I grew up in Toronto. I'm a Canadian, and I went to graduate school in Chicago at Northwestern University, and it was the late 90s. And there was this new technology called the internet that no one really understood at the time. And I was a PhD student in economics. And one of the things that in my field of economics you do at that time is try to find an industry to study. And I thought, well, since no one knew anything about this industry, no matter what I found, it might be interesting. And so I set about trying to understand the economics of the internet, focused at the time on advertising supported technologies. That led me to a job back in my hometown, the University of Toronto, where I studied online advertising. Online advertising, reason thinking about privacy. I did a bunch of work on the economics of privacy, and then the opportunities and challenges in privacy and data started getting me thinking about what machine learning meant and the value of data. And then with another hat that I have on at the University of Toronto, we run this program called the Creative Destruction Lab, which is a program to help science-based startups scale. In our very first cohort back in 2012, there was this company called Atomwise. And the CEO of Atomwise was a PhD student out of Jeff Hinton's lab at the University of Toronto. And he said he was using AI for drug discovery, artificial intelligence to find new drugs. And put yourself back 10 years ago, that just seemed crazy. The idea, no one really knew what we were talking about when we talked about artificial intelligence. And the idea that AI could help you discover new molecules, new drugs, just wasn't on anybody's radar. We had a handful more companies that were also using AI, but in all sorts of different industries. We had one in banking, we had one in insurance, we had another one in drug discovery. And then in our third cohort, I think it was, we just had this flood of companies calling themselves AI companies. And at that point, my co-authors and I felt like it was time to get our heads around this new technology. We had all built our careers studying the internet from the late 90s on, been 20 years. It was time to start thinking about something new. And this technology seemed to be incredibly exciting. And because of our lab, because of these startups that we saw, we had a front row seat in the transformation. And that led eventually to our first book, Prediction Machines, and now to our newer book, Power and Prediction.
Which must have been fascinating. So if you look at where you started, and obviously you were focusing on an industry, so you were studying an industry and you looked at the economics of the internet, and also economics and privacy that pertain to that. And now you're involved a lot in the new technology in the sense of looking at AI in detail. And obviously herein, as you've mentioned, 10 years ago, that there was this announcement that AI was used to find new drugs. if you look at that comparative of what you studied previously as to what you're looking at just now, is there a sort of subjective inclination to favor one over the other? Or what's your relationship with both of those from a comparative angle?
So now my research on the internet is almost like history. Okay, I try to understand what happened. And my research on AI is about what's happening right now. And then I have some newer research on quantum computing, which is, again, sort of through the same lens. I'll talk about that in a second, in terms of thinking through, if the technologies progress the way we might expect, what the most exciting opportunities might be 10 years from now. But all of it has this particular lens. It's an economist lens, which is when you think about technology, don't think about the details of how the engineering work. Instead, think about how it makes certain things easier. And with an economist hat on, when we talk about easier, we mean better, faster, and especially cheaper. And so when something gets less expensive, in Economics 101, we learned that you're going to do more of it. When coffee, more coffee. And so when I think about each of these technologies, I look at it through that economist lens. So what the internet did, it made search cheaper, it made transporting information cheaper, and it made copying cheaper. And you can map out the consequences from that. So cheap copying leads to some things that were obvious at the time, like copyright mattered. Think about Napster and file sharing and piracy, depending on what side of that debate you're on. And but it also meant that privacy was a big deal. Because of cheap copying, anything you say to anyone can now be instantly broadcast everywhere around the world for free. You're going to be a little bit more careful of what you say. And so we can see a direct mapping from what's gotten cheaper to the consequences. And so when AI came along, we spent a fair bit of time trying to think through what became easier because of AI. And once you really dig into what the current hype around AI is about, not just generally what you think about AI in the movies, but in terms of AI as machine learning, it's prediction technology. It's statistical prediction. So the excitement around AI today is driven by computational statistics. That's still very exciting because that's prediction. And prediction is fundamentally important because it helps you make better decisions. And so again, this framing of, okay, prediction's gotten cheaper. We're going to machine predict more and more places. Even some places that we never really imagined where prediction, where we were really doing predictions before, like in medical diagnosis. If you talk to a doctor 20 years ago, they wouldn't say they're doing prediction, but that's exactly what they're doing. They're taking data, they have your symptoms, and they're filling in the missing information that caused those symptoms. And so that lens informed my internet work, and it very much informs my AI work. Just thinking through, as an economist, what's gotten cheaper. When something gets cheaper, you do more of it. And then the complements to that thing become more valuable. So when coffee's cheap, in Econ 101, you learn you don't want to be in the tea business. That's bad. You want to be in the coffee business. But you really want to be in the cream and sugar business. And when we think about, in the context of AI, the question is, as prediction gets cheap, what becomes more valuable? What are those complements to prediction? What are the cream and sugar of prediction?
And this, if we look at, you've mentioned, you've just explained there the economist lens that you're looking at the situation from. And you're the author of not only the book Power and Prediction, which are two very influential and impactful words, but you've also written another book that pertains to a previous central premise around the economics, I believe, as well, of the technology. Is that correct?
That's right. In Prediction Machines, which came out 4 years ago, we introduced this idea of should think about AI as a drop in the cost of prediction. And the thing that gets more valuable are data, of course, but also what we call judgment, which is knowing which predictions to make and what to do with those predictions once you have them. And judgment remains inherently human. And we wrote that book thinking, okay, we understand what's gotten cheaper. We understand what the complements are. A revolution is about to start. And then, 4 years later, we were sitting around thinking, the revolution hasn't happened yet. Why hasn't the revolution happened yet? We can see that the technology is extraordinary, and we understand what it can do. But by 4 years after we wrote the book, and we were starting to think about our next book, it wasn't clear what that really anything fundamental had changed. And if you look at survey data on companies in terms of their adoption of AI, or whether they feel, even among those who have adopted, whether they feel they've gotten a real financial benefit from it, the vast majority haven't adopted at all. And even among those that have adopted, the vast majority think they haven't seen the benefit. And that led to us thinking through, well, why not? What's the real opportunity here, and why is it so hard? And that's the theme of our next book, of our new book, Power and Prediction.
Mm-hmm. Because I remember reading as well that prediction machines, which we were talking about, your first publication, that focuses on what strategists and managers really need to know about the AI revolution. And it was obviously a 2018 publication that would have been written a little bit prior. Do you think that having written that perceptions have changed? I mean, you underline as well, as I've mentioned in that book, that the economic framework for understanding AI is surprisingly simple, that pertains to this economist lens. Having written that and now moving to writing, obviously, power and prediction, what has changed in between that, and what do you want your readership to take away now from Power and Prediction?
Okay, so prediction machines provided a simple frame, and when we talk about it, when we present it, people who've read it, it's pretty clear. It helps people understand what this technology can do. But what's changed is there's a difference between can do and has done. And so what's changed in our understanding is we wrote it in 2017, came out in 2018. We understood what it could do, but we thought it was about to do that. And then when we sat down a few years later, we were just frustrated that potential hadn't come to pass. And so in Power and Prediction, the question we approached the book with was, well, why hasn't the revolution happened yet? And where we landed was that prediction technology, prediction machines, or AI, has a lot of the characteristics of what we call a general purpose technology. And general purpose technologies are technologies that do, but they do so through a number of small innovations. So there's the big innovation, but the big innovation itself doesn't make the difference. It's actually a bunch of follow-on innovations. Let me give you an example. So electricity is an example of a general purpose technology. Okay. Electricity was invented or it's discovered, I guess, earlier, but it was, commercial opportunities for electricity were invented over the course of the 19th century, perhaps most famously culminating in the patent for the light bulb, which was in 1880. Okay, so Edison, 1880, patents the light bulb in the United States. I know in the UK there was a competing light bulb patent. Okay, and it seemed like this revolution was about to. And the data for the US, it wasn't until the 1920s that half of households and half of factories were electrified. So it took over 40 years from recognizing the potential of the technology, the event that we think of as the core event, commercial technology, took over 40 years till half of households and half of factories used it. What took so long? Well, a light bulb in and of itself isn't that useful. So what they did at first with the light bulbs, they just replaced candles. Right? That's great. It's a slightly better, slightly lower fire hazard, although remember, electricity was still pretty risky in those days. But it wasn't that good. It was only once you realized you could reinvent a whole bunch of aspects of life that we started to get the benefit of electricity. So with a light bulb, that meant you could build different kind of buildings with much bigger interiors because you didn't need external light. You could more reliably work in the evening than you could before because your light source was more powerful and more consistent. You could, and then in terms of the electric motor, in factories, what they did, factories used to be run by steam engines. The steam engine was the center of the factory. And the most power-hungry machines were located close to the steam engine. The less power-hungry machines were located far away from the steam engine. And you basically had specialists who built most of the products on machines at a given place. You had artisans. What electricity originally did is that they took out steam engines, put in electric motors, and didn't do anything else. The workflow stayed the same. And it saved like 5, 10, or 15% on energy costs in some places. And in some places, it was worth it. But for most factories, that wasn't worth the bother. But in a handful of factories, they started to realize, well, we can redesign our factory to be what you think of as the sort of the quintessential 20th century factory, like the Henry Ford factory. Modular production, inputs in one end, outputs out the other, huge open spaces where with each worker doing one particular part of a big workflow. That was enabled by electricity. And once they reinvented how the factory, a whole bunch of other inventions, that's when electricity really took off and impacted society as a whole. And we expect the same thing for AI. Thought in 2018, you could just take it out, drop in the new thing, not change anything. A handful of places that worked. But in the vast majority of organizations, in order to get the benefit of much better prediction technology, you're going to have to start doing things differently.
And this is what you suggest in your book as well. I mean, I remember reading that you suggest that we're in the between times of AI after witnessing the power of this technology and before its widespread adoption. So this is why point and application solutions are currently the more attractive and sought after use cases of AI. Is that correct? I mean, what brought you to this opinion, Avi?
That's exactly correct. So we did an inventory of the AIs that we'd seen so far make a big impact on society, or at least on their companies. And society level, the inventory was shockingly small. But we found a bunch of use cases in companies that, the companies were happy. The particular director of that particular division within that particular company was content with the implementation. And for the most part, we used to be doing some kind of prediction, whether it was through a human was doing the prediction, or some good old-fashioned, say, regression analysis, old-fashioned statistical prediction, machine prediction. And we're replacing that old method with a new method, with machine learning, with AI. And it's enough better that we get a real payoff in the company. So we saw things like, it's a Canadian company called Verifin, which predicts financial fraud. And they had been doing that long before AI. They'd been doing that for years and years and years. And then AI came along, and they realized they could do what they were doing the old way much better. They replaced their old ways to predict financial fraud with machine learning tools, with AI, and it was much better. And then they were bought by NASDAQ for billions of dollars. So it's there's a handful of these examples of. But that's not going to transform the economy.
No, I mean, it's the same as rule-based predictions being replaced by machine learning. I mean, we've seen it and experienced it. Yeah.
Right. What's going to transform the economy is when we start to realize that better prediction can allow us to do things totally differently and create a new kind of value. There's a couple examples that we've seen that happen so far in. One is online advertising. But if you don't, so the old way to do advertising was a lot like Mad Men, the TV show. It really was that people sort of negotiated and took each other out for drinks and dinner and convinced each other that, we should buy ads in this way. And there was some kind of negotiated price. It's a very slow, old-fashioned process. And then with the rise of targeting in the internet, which is prediction technology, knowing you have a given user looking at a given page and you have a prediction about who they are and what they want, that led to an entirely new advertising ecosystem. So the way advertising works today is very, very different than the way advertising worked for buying an ad in TV or magazines, say 20 or 30 years ago. So there's been transformation there. The more clear transformation is in personal transportation. So about 10 or 15 years ago, two technologies came about. One was the mobile phone, which allowed digital dispatch. So it allowed taxi companies, it allowed you to call a cab from your phone, and it allowed taxi companies to get in touch with the taxi drivers and tell them where they were. That was an internet-related technology. But there was also a prediction technology there too, which was mapping, and navigational AIs that told you how to get from point A to point B in the most efficient way. And in the early days, in that industry, in the taxi industry, both of these technologies were sold into taxi companies. And so taxis actually got a little bit better at helping you find a ride and helping you get from point A to point B. But that's not how we think about these technologies today. What happened was a handful of people realized, well, once you have a good prediction about how to get from point A to point B, you no longer need expertise in how to get around. Okay, so like in the city of London, England, it is 3 years of training to become a taxi driver. Why is it 3 years of training to become a taxi driver? Because that city is a mess to get around. It's really challenging to figure out, I don't know if you spend time there, how to get from point A to point B.
Very much so.
And so it's all this training. Now, suddenly GPS comes along with navigational AIs, and almost anybody can be as good as a London cab driver in navigating the city. And so that changed, essentially upskilled all these people who knew how to drive, but didn't have the navigational skills. And that led to an entirely new industry of Uber and Lyft and ride sharing.
And that's a very positive example. I mean, if we were to take maybe a more dystopian view on it, and we look at the targeted advertising that you mentioned sort of previously, if we're using the predictive capabilities to really quantify and maybe turn the human into a quantifiable object, and predictions used more and more, and the accuracy of predictions lead to more control, essentially. Has this been regarded? I mean, is it common or an often occurrence that people come to you with concerns or fear or a perception that you're asked to address this component of the development of prediction?
Yes, it's a tool. It's not magic. It's not like true intelligence. It's a tool. Yeah. And like any tool, it can be used for bad or good. And there's going to be benefits and costs to that. Now, part of the challenge is in terms of it's very easy to figure out who a machine is, and it's very hard to reimagine what a new industry might look like. And so, and that leads to, I think, a lot of us to be pretty pessimistic about what the technology might mean. I personally, and I think my co-authors are too, much more optimistic.
Yes.
And I'm optimistic in a few ways. Okay, so the first one is, and this is I should have an important caveat here. I'm optimistic about the commercial application, the surveillance, and sort of there's a paper called AI-tocracy. That framing the political economy of it. That's not really my expertise, and I'll not say whether I'm optimistic or pessimistic, but I'm just going to say that's not what I know about really well. So that's what other people talk about. But in terms of the commercial opportunity, I'm optimistic in two ways. So first, when we think about jobs, okay, so we tend to focus on the jobs that will replace, okay, as opposed to the jobs that will create.
Yeah, it's a common narrative that people sort of slip into. Yeah,
and there's reasons I think to be very optimistic about the jobs it will create because it upskills. So that the taxi driver story, you don't think about taxi drivers as being relatively skilled, but what it did is there used to be in the US a couple 100,000 taxi drivers, and now there's millions of people who can make a living by driving because the constraints that used to exist, whether it was on navigation or other things, the taxi industry went away. But there's lots of other industries where that kind of thing can happen. In medicine, doctors have this special place because of their skills and training in diagnosis. Okay? If a machine's doing diagnosis, there's hundreds of thousands, or in the US, millions of other medical professionals who are very good at the other aspects of medical care, like helping patients deal with stress, providing treatment, et cetera, nurses and medical aides, pharmacists, et cetera. But they don't have that diagnosis skill. And if we can upskill all those people, that can create a much more inclusive, better medical system. And I think you can go industry by industry, and a lot of the people at that top of industries are there because of their prediction skills.
Mm-hmm.
If we can upskill everybody else, I think there's reasons to be optimistic about a reduction in inequality in terms of skill-based inequality because of these technologies.
Very much so. Okay. And I don't know if this pertains to this particular point, but you also mention in your book that the successful adoption of AI in general, it requires what you call the system mindset. Yeah.
For that to change, you need an entirely new system, right? Mm-hmm. As long as you're focused on taking out some current task, dropping in a machine, what you're going to get is job replacement. So the system level change, Uber was a system level change. Mm-hmm. The system level change, we can only get the optimistic view once we create the system level change. As long as we're saying, okay, let's keep our workflow the same, human, drop, and don't do anything else, then it has to be pessimistic. Now, I said there's two ways I'm optimistic. This is also about system level change. Much of the criticism around AI so far and its implementation has been around discrimination and bias.
Mm-hmm, yes.
That AIs are biased. Of course they are. They're based on human data, and humans are biased. And so if the AI is predicting what a human would do, and in terms of all sorts of decisions, whether credit scoring or hiring or a bunch of other areas, we humans are terribly, terribly biased. Mm-hmm. And since humans are awful, what can you expect from the AI? Now, so as long as we're in a system of, okay, let's just predict what the human would do, keep the process the same, we're going to have AIs that at least mimic, if not amplify, human discrimination. And that's a good reason for pessimism. But once we start thinking about system level change, well, we've got to be able to do better. As long as the person in charge of the AI cares about reducing bias and discrimination, it's really hard to change humans. And we know it's relatively easy to change algorithms. And so as long as, this is an important caveat, as long as the person in charge of running that machine is trying to reduce bias and discrimination, there's reasons to be optimistic that we can build machines, that we can build prediction machines that do much better than our awful human processes.
Mm-hmm. And what practical advice could you pass on then to ensure that this can be encouraged within organizations and business development?
This being?
Being that, you have someone that's actively ensuring that there is the evasion of a bias.
Right. So I think the first thing to do is to think through what are you trying to achieve? Okay, and you probably don't want one person, you probably want a team. And what are you trying to achieve in your hiring? And it's unbiased, but also to help the company. And then you'd have a step on thinking through, well, why isn't that working now in our company? Like if we have an AI predict who we hire, and the AI keeps telling us to hire men, well, what's wrong? Like, what are we doing wrong? And then to go out and try to gather data. Improve. What do I mean by that? There was a large company that built an AI for hiring. And the first pass at it was discriminatory. It didn't hire minorities and it didn't hire women. Why? Well, because in the past, they'd hired a lot of they'd hired a lot of white men. And so they had a pretty good guess about the performance of those people. Okay? And so where they'd hired very few women and very few underprivileged minorities. And so the AI just was very high variance. The predictions weren't good. And since the predictions weren't good, on average, it would say, this person's going to be okay. Like, no matter who it was, we have no idea, it's going to be okay. But since it was very hard to get a job in this company, if the best guess was the person was only going to be okay, they'd never get hired. Mm-hmm. This is, by the way, is based on work by Lindsay Raymond, Danielle Lee, and Peter Bergman out of MIT. And they said, well, you know what? The reason our AI is saying we don't hire women is because it just doesn't have enough women in the sample. And so let's, what we call explore, let's hire women with high potential, even though they're our best perform that well, to teach our system which kinds of women perform well in the company. And they did that, and it worked. And at first, they were just effectively randomly hiring among the people who could be high performers, some women. But then the system learned, and it worked. And over time, the system did identify the women who were going to perform well in the company, and the bias went away. This is about a system level change. It's not just, okay, take our current processes. It's about reimagining the hiring process around the recognition that predictions depend on data.
Fascinating. I mean, do you really feel that there is enough emphasis on actually motioning this type of change as well? I mean, we know that in everyday practices, there's a lot of prioritization that goes into certain process changes. And what we're talking about here, when we're looking at this sort of system alteration and change in mindset, I think personally that it might come down to prioritization that might not be there.
100%. So system change is hard. It's costly. It's risky. And so the payoff has to be huge. And so the leadership of the company has to think that it's worth it to go through this painful system change in order to get to the other side. And so that means the most successful of these system level changes have audacious goals. That so in discrimination, it has to be a company that really deeply cares and thinks that this is a fundamental barrier to their success. And more generally, whenever we're thinking through system level change, the payoff has to be something big, a reinvention of the industry, an entirely new way to provide value to the customer, a new kind of product, a new category of customer, and a new way of doing things. Because if ultimately it's just about reducing costs by 5% for a system change, who cares? It's just not going to be worth the effort.
And let me ask you one sort of last question before we usher our own discussion to a close. If you're looking, I mean, your own research, you've written numerous papers, which I'd like to read in the future as well. Your research focuses on the opportunities and challenges of the digital economy. So if we look at the research that you've done in the past and your current research, and we look at the digital economy and we sort of align that and bring in the system changes that we've been talking about, where would you want to place prominence when we're talking about system changes in the digital economy?
The reason we care about the digital economy is because of the system changes that have already happened and the potential for more. Okay? The task-based, the incremental stuff, look, it's interesting. The microwave oven was interesting. Okay, it like helped society in various ways, but we don't have books and papers written about the microwave oven because ultimately it was, a small piece of our overall lives. The reason we think about digital tech, for most of us anyway, the reason we think about digital technology or AI as being transformative, the reason I think it's been worth dedicating my research life to it is because of its potential for system level change. In digital, we've seen some of these system level changes already. We've seen it in advertising. We've seen it in the way we, in e-commerce, the way we buy goods and services, and a whole bunch of other areas, communication. And in AI, we're starting to see some of the potential of those system level changes. But without system level changes, who cares? Without system level changes, these are, technology is an incremental technology that happened before. And that's nice, but it's not the kind of thing that personally I'd like to dedicate my career to, and that I think your listeners would like to spend a lot of time listening to either.
Well, I'm sure they're going to enjoy the conversation that we've had today, because I've enjoyed it thoroughly. And I'd like to thank you for the time that you've taken to talk with us today here on Redefining AI, Avi. I hope that you too have enjoyed the conversation. Thank you very much.
Thank you. It's been great. Thanks, Lauren.
Thank you. So I'd like to thank everyone else for listening today. If you'd like to find out more about artificial intelligence, machine learning, and search, then go to the Squirrel Academy at learn.squirrel.com. Thank you.